Good morning, math people. Today we're going to look at solving a polynomial, finding both imaginary and irrational roots. So what we've talked about before, and by the way, I'm on page 9 of your notes. What we've talked about before is that the highest exponent, the degree of the function, tells us how many possible solutions we have. And those solutions could be both imaginary and real, or real and irrational. And we also talked about that imaginary roots and irrational roots come in pairs. So we're going to look at finding the specific imaginary and the irrational roots of a function, okay, of an equation. So let's look at this first equation. We have x cubed minus 8 equals 0. Now, that could have one real root, or it could have 3 real roots, or just 2. So that's what we're trying to determine. So what we're going to do is we're going to graph x cubed minus 8. So I'm just going to put x cubed minus 8, and to see what roots I can find from that. So x cubed minus 8, and I see that I have a solution at 2. Okay? So I have a solution at 2. So what that means, I have one real root, and it is at 2. So I have a real root at 2, which means that x minus 2 is a factor. Which also means that if I divide x cubed minus 8, if I divide that by x minus 2, I can find the other factor of x cubed minus 8. So that's what I'm going to do. I'm going to use synthetic division to divide x minus 2 by x cubed minus 8. So I take the opposite of negative 2, which so happens to be positive 2 here, the same as my solution. So I put my 2 here. Now remember, I have to represent every term. So I have to represent x squared, x, and then 8. Now, if I've done this correctly, and 2 is actually a root, then I should get 0 as a remainder. So let's see if that's true. So I'm going to start by bringing down my 1. So I have 1 times 2 gives me 2. 0 plus 2 is 2. 2 times 2 is 4. That comes down as 4. And 2 times 4 is 8. So my remainder is 0. So that means x minus 2 is a factor. And I'm left with x squared plus 2x plus 4. Now, how do I solve this? It is not factorable. So in order to solve this, I'm going to have to use the quadratic formula. So using the quadratic formula, a is 1, b is 2, and c is 4. So I have negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 4 all over 2 times 1. So that will give me negative 2 plus or minus the square root of, this would be 4 minus 16, which would give me negative 12 all over 2. So remember, the square root of negative 1 is I, so I can write this as negative 2 plus or minus I square root of 12 over 2. But I need to simplify that square root of 12. So that's when I will do my upside down box. 2 goes into 12 6 times. 2 goes into 6 3. 3 goes into itself 1. So the 2's come out, and I'm left with negative 2 plus or minus 2i square root of 3 over 2. Now, remember, I can do my triangle here. And so my solutions for this, my roots, remember, have 3. The first one is 2. The next one would be, if I divide everything by 2, I get 1 plus I radical 3 and 1 minus I radical 3. And remember, we can write that as 1 plus or minus radical 3i. and that represents 2 factors. So I have a total of 3. One plus or minus I radical 3. That's actually 2 solutions. So I have a total of 3. 1 and then that's 2, so that's 3. Okay? Let's do another one. Again, I have to start by graphing this because I don't know how to factor it. Well, actually I do, but you don't. So we have x cubed minus 4x squared plus x minus 4. Okay, once again, I see that I only have one solution, and that solution is at 4. I only have one real solution. So that means that x minus 4 is a factor. And I can divide this by x minus 4. So once again, I am going to do my synthetic division. So I have put my little 4 in a house here. And then I write my coefficients. 1, -4, 1, -4. I bring down the 1, and if I've done this correctly, I should get a remainder of 0. So 4 times 4 times 1 is 4. We add those together, we get 0. 4 times 0 is 0. We get 1. 4 times 1 is 4. And again, that adds to 0, so I am on track. All right, so be careful in writing your quadratic equation, because it would be x squared plus 0x plus 1. So once again, when I'm doing the quadratic formula, a is equal to 1, b is equal to 0, and c is equal to 1. So I have 0 plus or minus square root of 0 squared minus 4 times 1 times 1 all over 2. Okay? So, of course, I don't have to write this 0 and I don't have to write that 0. I just did it for effect. So I get the square root of -4 all over 2. And so the square root of 4 is 2. The square root of -1 is I. So this is plus or minus 2I, which would be plus or minus I. So my solutions are 4, I, and I. Those are my 3 solutions. All right, why don't you pause the video and do the next 2. Okay, welcome back. So for the next one, when you graphed it, I want to go ahead and get rid of this graph. When you graphed it, you should have gotten -3. So when we do our synthetic division, we get 1, 3, 5, 15. Bring down the 1. So we have -3, 5, -15, and yes, I got a 0. So I get x squared plus 5 equals 0. And when I do the quadratic formula, I get plus or minus the square root of 5. Okay? And you can use quadratic formula to verify that. And then on the next one, when I graph it, I have a solution at -2. So now be careful on this one. I will put -2 here, but I have x cubed. I have to represent x squared. So that'll be plus 0 plus, I don't know why I'm putting those pluses there. So it'd be 1, 0, 1, and then 10. We've done this correctly. That should be 0. We'll bring down our 1. So we get -2 And that is 2. Nope. That's 4. And this would be 5, and that's negative 10, which comes out to 0. So my equation would be x squared minus 2x plus 5. And then I would use quadratic formula. 2 plus or minus the square root of 4 minus 4 times 1 times 5 all over 2. So this is 2 plus or minus negative 16 all over 2. So the square root of 16 is 4. So this would be 2 plus or minus 4i all over 2. And again, we do our triangle, so we get 1 plus or minus 2i. And that would be our other two roots. Okay, so your homework tonight is to finish page 10 in your package. You have 4 problems to do tonight for homework. Okay, thank you very much, boys and girls. I'll see you tomorrow.